If you break an arm, an X-ray shows the crack.
Yeah, it's pretty undeniable.
Right. It's objective reality. You point to that jagged white line on the film and say, there it is, broken.
Exactly.
And I think we expect that same level of precision everywhere, especially when we're, trying to diagnose a problem or measure progress. But when you step into the world of behavioral science, that X-ray machine is, well, it's fundamentally broken.
It really is.
The tool you use to measure a behavior literally dictates the reality you end up seeing on your graph.
Because human behavior doesn't leave a static black and white image. I mean, it is fluid, it's highly dependent on context, and honestly, it's notoriously difficult to pin down.
Oh, absolutely.
If you choose the wrong lens to look through, your data isn't just slightly off. It is telling you a completely fabricated story.
And today, we are unpacking exactly why your data might be lying to you. Welcome to this deep dive. For you, the learner out there who loves getting into the actual mechanics of how things work, we are exploring the core playbook for board-certified behavior analysts.
The foundational stuff.
Exactly. Specifically, we're getting into taskless C9, which is all about selecting a measurement procedure to obtain representative data. We're pulling from a massive stack of BCBA mock exams, ethical workbooks, and applied behavior analysis study guides.
And whether you are managing a team's productivity, or tracking your own gym habits, or working in a clinical setting, understanding these mechanics will completely change how you view progress.
It's game-changing.
Because our ultimate goal in behavior analysis isn't just to gather a bunch of numbers on a clipboard.
Right.
It is to find the true underlying pattern of behavior while juggling the incredibly messy, unpredictable reality of everyday environments.
Okay, let's unpack this. Before we can even pick up a tablet or a stopwatch to measure a behavior, we have to figure out what exactly we're measuring in the first place.
It's essential.
I mean, it's a basic physics problem. You cannot use a ruler to measure a liquid.
No, you definitely can't. You have to define the physical dimension of the behavior itself. And that always starts with an operational definition.
Okay, so what does that look like?
Well, it must be objective, clear, and complete. We cannot use subjective terms. I mean, a huge mistake students make on the exams is selecting a target behavior like anxious.
Right, because what does anxious even mean?
Exactly. You cannot measure a child being anxious or a coworker being lazy. Those are internal states. They're judgments. You have to measure the observable actions in the physical environment.
So it has to be something a total stranger could walk into a room and instantly recognize based solely on your written description.
Precisely.
So let's say we have our objective definition. We know what we're looking at. How do we break down the physical dimensions of that behavior?
We look at a few distinct categories. First, there's temporal locus, which is the exact moment a behavior happens in relation to a trigger.
Okay.
A really common metric here is latency. Think of the exact amount of time it takes a student to finally orient toward their teacher after their name is called.
Got it. So the trigger is the name, the behavior is looking at the teacher.
Right, and the time in between those two things is the latency.
So that covers the when of it all.
Yeah. Then you have temporal extent, which is how long the behavior lasts once it actually starts. We measure that with duration.
Like a tantrum?
Exactly. The total time of a tantrum, from the very first scream to the final sniffle. And finally, there's repeatability, which is just how often the behavior happens. You can simply count it or measure its rate, which is the frequency, over a specific period of time.
But it's not just about time and counting, right? We also have to consider the actual shape and the intensity of the action. Let's talk about topography and magnitude.
Oh, these are crucial. Topography is what the behavior actually looks like physically in space. Consider a golfer, Hugo. Let's call her Amanda.
Okay, Amanda the golfer.
Right. She's trying to fix her swing, and her clinical goal is for her club to be 85% within 2 degrees of her planned swing path.
Wow, very specific.
Very. But that is pure topography. It is all about the exact physical form of the movement. Magnitude, on the other hand, is the intensity or force of the behavior.
So how hard you're doing something.
Yes. Imagine a client named James who is lifting 27-kilogram weights 20 times. The 27 kilograms represents the magnitude, the sheer physical force required to complete the behavior.
That makes total sense. I mean, if I'm trying to improve my tennis game, counting the rate of my swings is completely useless if the topography, the actual physical form of my swing, is terrible.
You're just reinforcing bad habits.
Exactly. I'm just getting really efficient at being bad at tennis. So how does a practitioner actually decide which of these dimensions is the critical one to track?
What's fascinating here is that the critical dimension depends entirely on the clinical goal and the inherent nature of the behavior itself.
Okay.
Let's look at a discrete behavior, something with a very clear start and end point. Imagine an adult in a workplace environment who repeatedly makes inappropriate jokes.
Oh boy. Yeah.
Every single joke is a discrete event. In this case, tracking the rating, the frequency of jokes over time, is the absolute best way to gather baseline data.
Because it's easy to count. One joke, two jokes?
Yeah, right. But what if you are looking at a behavior with highly variable lengths, like that tantrum we mentioned earlier?
Oh, I see where this is going.
A tantrum could last 2 minutes, or it could last 2 hours. If you only measure the rate, and you say, well, they had one tantrum today, that tells you almost nothing about the reality of the situation.
Because a 2-minute tantrum is vastly different from a 2-hour tantrum.
Exactly. Rate alone becomes entirely invalid for that behavior. You must measure duration to get the true picture.
Okay, so we figure out the dimension. We know whether we need to track the rate, the duration, or the latency, but then we have to figure out how to actually capture it over the course of a day.
Which is where it gets complicated.
Yeah, this brings us to continuous versus discontinuous measurement. Continuous measurement captures every single instance of a behavior. You are getting the exact frequency or the exact duration. It is highly accurate. So, why wouldn't we just use that all the time?
Observer drift and cognitive load.
Meaning it's just too hard.
It's exhausting. Watching someone constantly for hours isn't just tiring, it's practically impossible in a natural setting. You would have to stare at a person without blinking, completely ignoring the rest of your environment.
Which you can't do in a real clinic or a classroom.
No. That level of hyperfocus leads to burnout, and ironically, it makes the observer start missing things anyway.
So if continuous measurement burns people out, what is the alternative?
We use discontinuous measurement. Instead of watching constantly, we sample the time.
Okay, how does that work?
The observer divides an observation period into smaller, equal intervals. And there are 3 main ways to do this. First is whole interval recording.
Whole interval.
Yeah. For this, the behavior has to happen for the entire duration of the interval to be counted. If your interval is 10 seconds and the client performs the behavior for 9 seconds, it goes down as a 0.
Wow, harsh grading.
It is. Then there is partial interval recording. For this one, the behavior just has to happen for a split second during that interval to get a check mark.
Just once.
Just once. If it happens once for half a second, or 50 times for the entire interval, it is still just one single check mark on the datasheet.
Okay, and the third one?
The third is momentary time sampling, or MTS. For this, the observer sets a timer, and they only look up at the exact moment the interval ends.
Literally just a snapshot.
Yes. If the behavior is happening right at that exact second, it counts. If it happened 2 seconds before the timer went off but stopped, it doesn't count at all.
Okay, here's where it gets really interesting because I have to push back on this whole concept.
Go for it.
If we're only taking a snapshot every few minutes, aren't we basically creating fake data?
It can certainly seem that way.
Think about the mechanics of partial interval recording. If a kid yells for literally 1 second, that 1 second gets marked as if the behavior was present for the entire interval.
Correct.
My graph is going to show a kid screaming constantly when he barely made a peep. How is that scientifically acceptable? Our data is technically a lie.
That distortion is exactly why behavior analysts have to be incredibly careful. We call these measurement artifacts.
Measurement artifacts.
Yes. These are data points that appear to exist only because of the flawed way they were measured. Because of how it collapses time, partial interval recording naturally overestimates the occurrence of a behavior.
It makes it look way worse than it is.
Exactly. It makes it look like it's happening much more often than it actually is. And whole interval recording does the exact opposite.
It underestimates it.
Right. It naturally underestimates behavior because if the behavior drops off for even a fraction of a second, the whole interval is completely discarded.
Okay, so if we know these discontinuous measures create measurement artifacts, if we literally know the tool itself is inherently flawed, why on earth would we ever use them in a clinical setting?
We use them because we can be strategic. We can pair these specific artifacts with our clinical goals to guarantee that we are making real, undeniable progress.
Oh, that's clever.
It's a massive concept for the exams, actually. It's about intentionally matching the measurement flaw to your desired outcome.
The matchmaker game. Let's walk through this, because this is wild. Let's say we have a preschooler. We'll call him Junior.
Okay, Junior.
He tends to wander around the classroom instead of engaging during free choice time. Our clinical goal is to increase his engagement in the activities. What tool do we use?
If you want to increase a behavior, you use whole interval recording.
Because it underestimates.
Yes.
Yeah.
We know that whole interval naturally underestimates behavior. It is a heavily conservative measure. It is incredibly tough to get a check mark because Junior has to be engaged for the entire interval without stopping once.
I see. So if our data shows that Junior's engagement is actually going up on the graph, despite the tool actively underestimating his progress, we know for a fact that the intervention is working.
Exactly. We haven't accidentally inflated the numbers.
Now let's look at the reverse. What if our goal is to decrease a behavior? Consider a first grader. Let's call him Nolan.
Poor Nolan.
Yeah, he chews his shirt constantly, which ruins his clothes and gives him a severe rash around his mouth. The family and the school need this behavior to stop. For decreasing a behavior, we use partial interval recording.
Because partial interval overestimates behavior. It is hypersensitive. If Nolan chews his shirt for even 1 second, the whole interval is marked as a failure.
Wow, okay.
Therefore, if our data shows that Nolan's shirt chewing is dropping down to 0, we are absolutely certain the behavior is truly gone. We haven't missed any sneaky 1-second chews.
And just to round out the strategy, if you are simply trying to eliminate a highly discrete behavior, something with a clear start and stop, like a student who frequently picks his nose, you don't need complex interval.
No, not at all.
You just use rate. You count the picks per minute to establish a baseline and then track the reduction over time.
Exactly. You mash the tool to the specific nature of the behavior.
So what does this all mean? We are essentially grading ourselves on a curve.
We really are.
We intentionally pick the measurement tool that is the hardest to satisfy for our specific goal, so that when we finally see success on the graph, it is absolutely undeniable.
If we connect this to the bigger picture, this is the essence of effective behavior analysis. You are proving beyond a shadow of a doubt that your intervention, and not just a data glitch or a measurement artifact, is what actually changed the behavior.
It's brilliant.
Imagine a supervisor running a supported employment center. If she divides her workday into 100 equal intervals to track on-task versus off-task behavior, she is creating a stringent, undeniable metric of engagement over the total opportunities.
But let's do a reality check here. In a pristine laboratory setting, maybe we could just use continuous, perfectly accurate measures all the time.
Yeah.
But the C9 task list explicitly states that we have to account for environmental constraints.
And that is huge. Real-world environments dictate the tools we can use. Take a typical classroom with 30 kids, or a chaotic open clinic setting.
It's chaos.
A single teacher cannot continuously track every single instance of one student's behavior while trying to teach 29 others. It is physically impossible.
So they have to use feasible tools.
Yes.
They might use momentary time sampling, setting a vibrating timer in their pocket to just check in every few minutes, or they use play check.
Right, planned activity check.
Yeah. That's where you scan an entire group of people at once at a specific moment to see how many are engaged in the target behavior.
And this brings us to a critical distinction that every practitioner must understand. And honestly, it's a trap a lot of students fall into. It's the difference between reliability and validity.
Okay, break that down for us.
You can have a measurement system that works perfectly in a busy environment. It might be highly reliable, meaning it produces consistent results every single time. But is it actually measuring what you think it's measuring? That's validity.
Right. It's like stepping on a broken bathroom scale. It might give you the exact same weight 3 times in a row, so it's highly reliable.
Very consistent.
But if it's off by 20 pounds, it is completely invalid.
Exactly.
Let's go back to the nose-picking example from earlier. Imagine you are tracking a child's behavior from the side of the room. Every day, you record exactly 8 to 10 occurrences.
Very reliable data.
Right, it's perfectly consistent day after day. But then one day, you walk to the front of the room and look closely at the child's face. You realize the child isn't picking their nose at all. They're picking a scab on their cheek.
Your data was highly reliable, but it was entirely invalid. You were not measuring the correct behavior.
I have to ask, is having highly reliable but invalid data actually worse than having no data at all?
This raises an important question, and the answer is absolutely yes.
Really?
Invalid data is incredibly dangerous because it provides a false sense of security while leading you to treat the wrong problem.
Oh, wow.
You might build an entire behavioral intervention around nose picking, using specific reinforcements or redirections, when the real, functional issue is wound care. If you define the target behavior poorly, your reliable data is worse than useless. It is actively misleading.
And we have to ensure our data collection systems are actually appropriate for the staff who have to implement them, right?
Absolutely. That's tied to our ethical code, specifically Code 2.17.
There's a scenario often discussed in the study guides about a behavior technician, let's call him Sam. Sam is consistently turning in his session notes late, which just messes up the whole clinical analysis pipeline.
It's a common issue.
Huh?
But upon investigation, it turns out Sam is turning them in late because the data collection system his supervisor designed is way too complex.
He's overloaded.
He is trying to juggle stopwatches, clickers, and multiple data sheets while actively treating a client. The system itself is causing the delay.
So the functional solution here isn't to reprimand the employee for being late.
No, not at all.
The solution is to simplify the measurement system, make it realistic for the environment, so you can actually get valid data without burning out your staff. If the tool is too heavy, the worker drops it.
Exactly. When you look at all of these elements together, it becomes clear that selecting a measurement procedure isn't just an administrative task. It's not just picking a chart from a drop-down menu.
It's much deeper than that.
It is a constant balancing act between scientific precision and practical reality. You are aligning the true physical dimension of the behavior with your ultimate clinical goal, while somehow surviving the chaotic reality of the environment you are in.
And for you listening right now, this matters even if you never step foot in a behavior clinic.
Truly.
Whether you are tracking your own habits at the gym, managing a team's productivity at work, or evaluating the success of a new business launch, the measurement tool you choose will literally dictate the reality you see.
It frames your entire perspective.
If you pick the wrong tool, you end up chasing measurement artifacts instead of real results. You end up fixing the wrong problems, just like the broken scale.
There is one final fascinating phenomenon to consider here, often referred to as reactivity.
Oh, this is the idea that simply placing a human observer or even setting up a camera in a room to measure behavior often changes the behavior itself.
It's the psychological equivalent of the observer effect in quantum physics. The mere act of measuring alters the state of the thing being measured.
Let's think about the behavioral mechanism behind this. That clipboard or that observer sitting in the corner isn't just a passive recording device.
No, it's a stimulus.
Exactly. To the person being observed, that clipboard becomes an antecedent stimulus. Its presence in the environment might signal that punishment is available if they misbehave, or it might signal that reinforcement is available if they perform well. Simply by introducing the measurement tool, you have fundamentally altered the environment.
The baseline you are capturing is no longer a natural baseline. It is a baseline of how the subject behaves while being watched.
So I want to leave you with this to chew on. If the mere act of measuring a behavior alters it, are we ever truly capturing an objective reality? Or are we, simply by standing there with a clipboard or an app, always a confounding variable in our own data? Next time you try to measure something, whether it's your child's behavior, your team's output, or your own screen time, ask yourself if the invisible X-ray machine is showing you the truth or just the picture it wants you to see. Thanks for joining us on this deep dive.